Hello, hello everyone. My name is Krishna Mahapatra. I am from Barampur. Currently, I am pursuing my BTech from Parla Maharaja Engineering College in Barampur. I am in second year. This internship is provided by Emergy Information Technology Bangalore. I have done my internship in IoT-based home automation. So in this content, what we learn in the internship. So first is what is IoT, then what is embedded systems, then topics learned during internship, then about the project and requirements, then the demonstration of the project and conclusion. Now, what is IoT? IoT, the Internet of Things, may be a system of interrelated computing devices, mechanical and digital machines, given unique identifiers and therefore the ability to transfer data over a network without requiring human to human or human to computer interactions. Technologies that facilitates communication between devices over the internet. IoT systems works through the real-time collection and exchange of data. These devices range from ordinary household objects to sophisticated industrial tools. With more than 7 billion connected IoT devices today, experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 25. And this is the simple architecture of a Internet of Things. And then is embedded system. Embedded system is any combination of hardware and software which is intent to do specific tasks can be called an embedded system. Embedded system has three parts, that is software, firmware and hardware. Unlike computers, embedded system perform few specific limited tasks. Generally, they are comprise a processor, power supply, memory and communication ports. These are some types of embedded systems: standalone, real-time, network, and mobile. Example is CAT scanner, electric vehicle, household appliances, implemented heart monitors, etc. Then this is the architecture of an embedded system. And moving to next, then what we learned in the internship is first we learned the basics of C programming, that is keywords, basic data types, int, character, float, double, void, then operators, conditional constructs and looping concepts, then array, pointer functions, built-in and user-defined functions, storage, class, preprocessor directives and header files. Then C++, then we know something OOPS concepts, then constructs and destructors, then classes and objects, etc. Then about the project, we have three projects. That is, first one is to control the garden lights, then is the temperature control system, then third one is cereal tank volume control. So moving to first one, light controls. In garden light controls, we required a LDR sensor and LEDs. Process is to read the LDR sensor value based on the reading from the LDR, vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. During day, turn off the light, and during night, turn on the light. This is the concept we use in garden light control. Then we see temperature control system. In temperature control system, we need a temperature sensor. Then process is the read the temperature from the temperature sensor, that is we use LM35. Then output is the display the temperature on the gauge weight, display temperature on CLCD. Then which is cereal tank volume control. We need a cereal tank. Then process is the read the volume of the water in the tank by sending command through serial communication. Then output is the display the volume of the water on gauge weight, display the volume of the water on CLCD. Then the projects require, these are the project requirements. We we are I divided into hardware and software parts. In hardware, we required Arduino Uno, LED, LDR sensor, LCD, LM35 temperature sensor, temperature control system, Ethernet shield, and PCF8574. In software parts, I need Arduino IDE, PixSim Lab, Blink IoT app, and null modem emulator. First is hardware. Arduino Uno. Arduino Uno is based on the 8MB38P microcontroller. The board consists of digital and analog input and output pins, shields, and other circuits. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and an ISP circuit serial programming header. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. Then is LDR sensor. An LDR is a component that has a variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. This is the sample of a LDR sensor, and this is the graph. Then LCD. LCD I have used HD44780 LCD. LCD HD44780 is dot matrix liquid crystal display control and driver LSI display alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microprocessor. And this is the sample of an LCD display. Then temperature sensor. I have used LM35 temperature sensor. The temperature is recorded using LM35 sensor, which reads the analog value. The value is converted into binary value, and later the actual temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibration or trimming to provide accuracy of plus or minus 0.5 degrees Celsius at room temperature and plus or minus 1 degree Celsius over the minus 50 degrees Celsius to 155 degrees Celsius temperature range. The output scale factor of the LM35 is 10 millivolt per degree Celsius. For instance, it provides an output voltage of 250 millivolt at 25 degrees Celsius. This is a sample of an LM35 temperature system where it has a ground, output, voltage output, and voltage input. And this is a graph of an temperature system. Then temperature control system. The temperature can be regulated using the heater and cooler. The heater increases the temperature while the cooler decreases it. The are shown in the CLCD as well as the status of the heater are shown in the blink cap. The blink cap connected to Arduino Uno and CLCD and temperature system. Then Ethernet shield. I have used TS5500 Ethernet shield. The 5500 chip is a hardware TCP or IP embedded Ethernet controller that enables easier internet connection for embedded systems using SPI, that is serial peripheral interface. It is possible to use 8 independent hardware sockets simultaneously. W5500 enables users to have the internet connectivity in their applications just by using the single chip in which TCP or IP stack, that is 10 upon 100 Ethernet MXC and PHY embedded. It supports power down mode. Then PCF 857. The PCF 8574 is a silicon CMOS circuit. It provides general purpose remote I/O expansions for most microcontroller families via the 2-line bidirectional bus 12C. The device consists of an 8-bit quasi-bidirectional port and 12C bus interface. Then moving to for software parts, I have used Arduino IDE. The open source Arduino software IDE makes it easier to write the code and upload it to the board. This software can be used within an Arduino board. The Arduino IDE supports C and C++ programming languages. Then going to PixSim Lab. PixSim Lab is a real-time emulator of development boards with integrated MPLABX or AVR GDB debugger. PixSim Lab supports some PixSim microcontrollers and some SimBar microcontrollers. PixSim Lab have integration with MPLABX and Arduino Uno IDE for programming the boards of microcontrollers. And this is the software interface of Arduino PixSim Lab. Then Blink IoT app. Blink was designed for the Internet of Things. It can control hardware remotely. It can display sensors data. It can store data, visualize it, and do many other cool things. Create widgets on mobile Blink application. Button widgets to control the heater, cooler, inlet valve, and outlet valve. Gauge widgets to display the temperature and volume of the water in the tank on the mobile application. And this is the interface of the Blink mobile application. Then I have used null modem emulator. The null modem emulator is used in this project to establish the serial communication between Arduino IDE and PixSimLab. Then this is a simple demonstration of the project where I have connected the pins into Arduino Uno. I have connected CLCD in A5 and 4 pins, temperature system in A5, 4 and A0 pins, Ethernet shield in 12, 11, RST 10 and 13 pin, and LDR sensor to A1 pin and LEDs to 3 pin. And Blink app I have connected V1 to temperature, V1 for temperature sensor reading, V2 for heater button, V0 for cooler button, V3 for volume, V6 for notification, V4 for inlet valve, and V5 for outlet valve. Now I am going to show the source file for the project. I have used this, and these are the codes that are required for our project implementation. I will give a demonstration of our project. So here is the PixSimLab. We have already dumped the code into it. Here is the spare parts that are actual model of our project. Here is our serial remote tank that now I will mirror my phone to show the Blink IoT app. So we can see the home automation system. So we have widgets to control the buttons for cooler and heater. In tab 1 there is a gauge to measure the temperature. There is a notification base where we can see the notifications. There is another tab to control the water volume, even where we use widgets for inlet and outlet valve buttons, and also gauge to measure the volume of water. Once we on the heater, the CLCD shows the heater is on and temperature starts rising. Once it off, the temperature starts falling. And if I on the cooler, the fan starts rotate and temperature comes down quickly. If the temperature of the room exceeds 35 degrees Celsius, the water will turn off automatically. So in the notification shows the actually that and temperature starts falling. Now talking about serial water tank. Once we click on the outlet valve, water starts moving out. Once the water falls below 2000 liter, the inlet valve turned on automatically. And to ensure the enough water available, and once the tank filled, the inlet valve stops automatically, so there is no wastage of water. We get notification in the water level is full, so turning off the inlet valve. Talking about LEDs, when there is no light available outside, more is the resistance. The LED will glow fully. If there is bright outside, the LED will turn off automatically. Moving back to our present conclusion. We simulated IoT-based home automation solutions with features like automatic guardian lights, temperature system, and cereal tank. We used Blink IoT application, Arduino IDE, Pixel Lab to this project. CLCD acted as a dashboard, button widgets and gauge widgets to control the display, certain tasks respectively. Now I will thank Emergy to give me opportunity to present myself in this internship. Thank you.